So for the next part of this question, we need to find the encoded messages that Alice actually sent and which packets were corrupted. So from the previous part of this problem, we found the values for the coefficients of Q of x as well as the value for b in E of x, the error polynomial. So like if we remember that E of x takes the form x minus b, we found b to be 3, so we know that E of x is equal to x minus 3. And Q of x takes the form of a 3-degree polynomial, a degree 3 polynomial. So we know that the coefficient a3 is equal to 1, so x to the power of 3 plus the coefficient a2 is 3, so 3x squared plus the coefficient a1 is equal to 3, so plus 3x, and the coefficient a0 is just 2, so plus 2. And if we wanted to find the original polynomial p of x, we would have to use polynomial long division to divide q of x by 3 of x. So x cubed plus 3x squared plus 3x plus 2 divided by x minus 3. And I'm not going to go over polynomial long division for this problem, but if you do run through the entire long division process, you come up with x cubed plus 6x squared, or x squared plus 6x plus 21 plus 65 over x minus 3. And since this is all still being taken mod 5, since we're still like working under this Galois field, if we also need to take this polynomial mod 5. So mod 5, it's congruent to x squared plus x plus 1, and this, since 65 is equal to 0, is congruent to 0 mod 5, would just end up being 0. So this is the p of x that we're left with. And so if we want to find the original message, we can plug in the points 1, 2, 3, 4, and 5. So if we plug in 1 to this equation, so 1 squared plus 1 is just equal to 3 for x equals 1, x equals 2. You get 2 squared plus 2 plus 1, which is equal to 7, which mod 5 is just 2. X equals 3. 3 squared, 9, or 3 squared plus 3 plus 1, which is 9 plus 3 plus 1, 13, which is again congruent to 3 mod 5. X equals 4. 4 squared plus 4 plus 1, which is equal to 16 plus 4 plus 1, 21, which is congruent to 1 mod 5. And at p of 0, at x equals 0, so we do 0 squared. We do 0 squared plus 0 plus 1 is equal to 1. So just squared plus 0 plus 1 equals 1, which is equivalent to 1 mod 5. So the final message that we're left with is 3, 2, 3, 1, 1. And if we compare that to the received message, we have 3, 2, 1, 1, 1, which I'll write in red. 3, 2, 1, 1, 1. We can see that here it doesn't match up. It doesn't match the initial message. So we know that the value at x is equal to 3, since this is the third x value, is the corrupted message. And again, this also corresponds to the value of b that we found here, since b is equal to 3. So, yeah, that's how to go through this question.